Sketch the graph of the rational function. First thing we want is the domain of our function. Anytime you graph a function, you'd like to know the domain. We are going to factor our function here. Our numerator is already as factored as it can be, but the denominator we can factor. We can pull an x out of that, and we're left with an x squared plus 8x plus 16. And this here also factors a little bit more. So we have x, and then x plus 8x, x squared plus 8x plus 16 is actually x plus 4 squared. So we know that our denominator cannot be 0 for our domain. So our domain here, x can't be 0, and x plus 4 can't be 0. For our domain, we have all real numbers except we must make sure that x is not equal to 0 and x is not equal to negative 4. And there's our domain. Next, for rational functions, you always want to reduce it because the reduced form of the fraction is a lot easier to work with than the original form. Now, we have to find the domain before reducing it because after reducing it, the domain actually changes for your reduced form, but we want to know our domain for the original. So for our reduced form, we just look at our factored thing and we cancel any common factors. And we do have a common factor of x plus 4. We cancel it out there, cancel it here, drop that exponent down to 1. And so our reduced form is, I like to use the lowercase r of x for this, 1 on the top because nothing was left over there, over x times x plus 4. Now we're going to use this reduced form to find holes. The holes of a rational function, we look at these the numbers that we can plug into the reduced form that we can't plug into the original. Now, it turns out that there's actually nothing like that because even though we canceled an x plus 4, we didn't cancel them completely out. So the domain of this reduced function is the same. That means that we have no holes. Next, we want vertical asymptotes. And vertical asymptotes are simply the zeros of the denominator of the reduced form. So we have vertical asymptotes. We have x equals 0 because of this x, and x equals negative 4. Next, we find intercepts. So we need our y-intercept and x-intercepts. For the y-intercept, we plug 0 into our function. Okay? Now 0 is not in the domain of the function. So there is no y-intercept. For x-intercepts, we find the zeros of the original numerator, okay? But they have to be in the domain. So you can actually work off of the reduced form as well. The zeros of the numerator are none because there's no x's up here. The numerator is never 0. So there are no x-intercepts either. Okay, now we find horizontal asymptotes. For horizontal asymptotes, we look at the degree of the numerator and denominator. And you can work off of the reduced form for this as well. The degree of the numerator is 0. There are no x's up here. And the degree of the denominator is 2 because we've got an x squared. When the degree of the numerator is smaller than the degree of the denominator, then your horizontal asymptote is y equals 0. All right, we are now ready to sketch this function. So we don't have any holes, so we can't draw anything there. But we do have a vertical asymptotes at x equals 0 and x equals negative 4. So let's go ahead and draw out our scale for this. There's our negative 4. Okay, and we have an asymptote there at negative 4. And we have an asymptote at 0. That's the y-axis. Okay, we don't have any intercepts, and we have a horizontal asymptote at y equals 0. So we can draw that as well. All right, there are no points here that we know. No points, no holes, no intercepts. We just have some asymptotes. So there's all kinds of things that could happen. I'll just do a few of them, right? We could have something like this and this and this, or we could have something like this and this and this, okay? Or we could have this and this and this. Okay, all kinds of possibilities here. And since we have no points, we just have to start plugging some things in to kind of know where we're at. Now, the nice thing is we know we're never going to cross the axis, okay? That's going to help us a lot. And it turns out we actually only need really 1 point, and then we can find out everything else from there. I'm going to plug in the easiest number I know to plug in here, which is just 1. Okay? And plugging 1 into this reduced form, we've got 1 over 1 times 5, so 1/5. Okay? So over at 1, I'm at 1/5. I got some point here, all right? Now that tells me right away what this branch looks like. We're above the x-axis here, so we can't cross it, so we have to stay above the axis. So we've got to go up like that and follow down here. Okay. Now we know the behavior of a function around the vertical asymptote by looking at the exponent on the factor that gave us that vertical asymptote. Okay? If it's even, it does the same thing on both sides. If it's odd, it does different things on both sides. So x equals 0 came from this factor right here, x. And the exponent on that is 1, which is odd. That tells us it does something different on both sides of this asymptote. So since it's going up on the right, it has to go down on the left. Okay? And I cannot cross this axis. I can't cross because I don't have any x-intercepts. And so I have to turn around, come down like that. And now again, this asymptote at x equals -4. That came from x plus 4, which has an exponent of 1, which is odd. And that tells me that it does different things on both sides of this asymptote. So since it's going down on the right, it has to go up on the left. And then I follow my asymptote. Follow my horizontal asymptote, never cross. And there's the sketch of my rational function. Now, if you don't want to sketch it using the behavior around an asymptote, you can always just plug numbers in from each section. I could have plugged in a -1 and found a negative number, and that would have showed me that I was below the axis for this section. And I could have plugged in here a -5, and that would have given me a positive number, and I would have known that my function was above the axis for that section. So it's up to you whether you plug points in or you use the exponents on these factors to know the behavior of the function around the asymptote.